Okay, let's start. Last class, we talked about the DDL for create table, drop table, and alter table. So up to this point, we know how to define the database schema here. So if you see the next page of the slides, this is actually queries. And the reason I put a query here is because the next topic after query is, hold on, to go down. Yeah. So the next one after query is called updates in SQL. So it's including insert, delete, update. And in this part, we are going to have something utilize query. That's why the PowerPoint slides organized like this. And when we teach it, when I teach this, actually I need to do slightly different order. So let's see, for the SQL section, we have first part is the it doesn't recognize my pen for reason. Wait. Okay, so we learned three things in SQL. One is create schema, the create table, drop table, alter table. Second one is how to run queries. Like, for example, I want to see how many employees in computer science department, right? So those are queries. And the last one is how to do insert, delete, update, means we can put instance into the database. So I'm going to skip the query and talk about this part first. And then after that, we'll go back to the query section. The main reason for doing this in this order is once we finish insert, delete, update, you are ready to do your SQL assignment. So let's see this. And we have another assignment on the query. Okay, so let's see the insert statement. For insert statement, we have the following syntax. So to insert into, and then we specify the table name. So when we have this, we need to have the table definition. So let's see the employee table. If we define our table using create table statement as first name, middle initial, last name, social security number, things like that, then we can put the value accordingly. Okay, so this is one. When you do this insert statement in this way, you need to be very careful to see how the table gets defined. So for example, if we define last name as the first attribute, then when you insert like this, the DBMS will not recognize you switch the first name and last name. So this is Richard is first name, but if you define last name is the first attribute, they will take Richard as the last name. In other words, the way you define your schema tell you what is the order to insert using this statement. So this is a case that every single attribute you have a value. What happened if for address, for example, right? So say address here, I do not know the address. And in the table definition, there's no requirement about no-to-no constraint in there. So in that case, what can we do? So what you can do is you can instead of put the address, you can put the no value there. So this whole piece can be replaced with no value like that. Okay, so that is a way to specify. Okay, and then let's see another way to do insert statement, sometimes more convenient. That is not only you give the values, but also you specify the column names. Okay, the benefit of this is when you specify this, you do not need to follow the same order as you create table statement. Okay, so you can do them any order, but once you specify particular order here, the value insert, when you say values, this order must according to the order you specify here. So they are simply matching by position. So Richard is the first name because you do the first name here and the last name here. Another benefit is you do not need to give all the values, all the attributes here. So employee table has 10 attributes. You only have 4 here. That's fine. It can be a subset. So by default, if we say here, you don't see address, right? So if there's no address, then we'll see if the attribute has default or not. If we do, then default value will be there. Otherwise, the null value will be there. So this one tell you, you have to put attributes that specify no-to-no constraint. And without a default, you have to have something here. All right. Okay. Okay, so that's for the insert. So sometimes, you know, I prefer this way, although you have more typing. So sometimes even I do 10 attributes, sometimes I type all of them. So it just to make sure whatever I inserted exactly what I want to insert, right? So like a switch first name, last name can be something like hard to notice, but it can give you a problem, right? But either way is fine. So whenever you want to use it. So that's for the insert operation. And so this is another slide about insert. And this part, the insert statement actually including a query. And I'm going to skip this page for right now. I'm going to come back to this at the end of the SQL section. So no worry, we're going to cover this for sure. So right now you need to know is this page, how to do insert using this way. The next operation we have is delete operation. So insert allow you to put allow you to put the values instance into the database, right? The records. And the delete operation is the opposite. So say we have an employee leave the company and I want to remove this record from my table. So how can I do it? So I use the delete statement. Okay, so one thing you're going to see in query also is the where clause. So this where clause serves as a filter. So you see the filter, we have something called a select operation in relation algebra, but actually it show up in the where clause in SQL query. So when we say where, this is a condition, it's a filter there. So let me see this whole delete statement. First of all, I do delete from, and I specify table name. And then the where part specify what are the filter on top of the employee table. So if I go back to, actually I have to have the relation algebra slides open. Let me get that one. I want to show you the employee. Okay, so I want to show this to you. Basically, I have all the employees here, right? So I want to have the where clause in the previous page. It said the last name equal to Brown. And so we will see for the delete statement, right? Delete from the employee table and the last name is Brown. And so I want to check the first record to see the last name is Brown or not. The answer is false, right? This last name is Smith, so the answer is false. So if it's a false, the delete operation will not apply to this tuple. So in other words, this tuple will stay in the table, okay? It's just still there. The second one, still false, so still stay. And the next one, actually none of them satisfy the condition. So that means that delete statement, our delete statement is delete from employee where last name equal to Brown. And in this particular case, if say this one has 8 tuples, and every single tuple when we evaluate always false. So all of them state that delete statement does not delete any single one. Okay? Even we issue the delete statement just because the condition is false, nothing get deleted. Okay, so go back to this. Okay, so that's for the first delete statement. The second delete statement actually targeting more specifically compared to the first one. So the first one, whenever the last name equal to Brown, okay, you can have, say, 3 employees named Brown, then all of them will be removed from this table. But this statement, since SSN is the primary key, so we are going to delete 1 and only 1 employee. So in this case, whenever you want to delete something, you say this is the only record I want to delete, you want to use the primary key to help you. To avoid situation, I want to delete the whoever like last name is, Jerry Brown, but actually you accidentally delete other Browns also. So that's one way you want to pay attention for delete statement. Okay, let's see this delete statement. This is when utilize a query. So I'm going to skip that. We're going to skip this for right now. In SQL, you probably already noticed anything we have a string that's a single code. Okay, so Brown single code, and this SSN here depends on how you define SSN. So if we define this as a character string of 9, because we want to restrict only 9 characters for social security number, then that's still a string, right? So it's a very character or fixed length character. So that's why we use single quote here. And if we have a number, say department number is an integer, then we directly say D number equal to 5. That's good. Okay, so let's skip this and I'll come back to this verse at the end. And then the last one, so delete from employee. This is interesting one, okay, depends on how you interpret things, okay. Think about the one I did here. So this is a filter to say yes or no, we delete it, right? And since I don't have anything, if we don't have where clause, okay, in SQL, no matter delete statement or queries, no where clause means where true. So in this case, when we say delete from employee, we are going to go to the first record, right? The first tuple, and they say delete true. Then what happened? The first one get deleted. So nowhere clause means true. And the second one, same thing, true, get deleted. So eventually everything in this table will delete it. It means you don't put a filter there, everything get deleted for delete from. One more thing interesting is when you do this simply remove all the existing tuples from the employee table. But the table definition still there. So if you already define using create table statement, whichever the schema still there, And if you want to remove the table definition totally, remember we talked about this, we need to use drop table statement. A drop table will remove everything, and the delete statement will only remove the tuples. So that's the big difference. And the next one is the update statement. So what is the update statement? This is the one means if we want to change a given value, we want to change something in the given record. Can be one record, can be many records, but we don't want to delete a record and insert again. Okay, what can we do? We can just using the update statement directly. So in this case, let's see, we want to change the location and the controlling department of project number 10 to this following value, right, to this. And so what we need to do is we say update project. And that is we specify which table to update. So one thing I want to ask you to pay attention is similar to other language. So SQL has a syntax. You just have to follow it. So if, for example, if I say set at the first one, then we'll do update. The query processor will be confused. It will not run the statement, similar to other language, right? So any language you have particular scheme and grammar. So you just say update and give table name. And we say set, okay? And this statement tell you the new value you're going to put into the system, regardless what is the old value. So when you do the update statement, you don't need to care about the old value. You don't need to specify old value. This is the new value you're going to put into the system. And this where clause tell you which record to change. So let's say you do P number equal to 10, this one will locate the only one record in the project because this is key, right? And then for that given record, we can change the location and also the department number. Depends on the condition here. So if we say where P number is greater than 10, for example, then it is possible you can have 3, 5, or whatever numbers, you have 5 records that have the P number greater than 10. Then for these 5 records, every single one, the location will be changed into this and the number into 5. So be careful to set the condition to know exactly what you want to do. So after, so for the where condition here, and also in the delete, you have where, right? So for the where part, you can do complicated conditions. So we can do P number equal to 10 and, something, and it can do and something. You can even do or. So this is pretty much like the relation algebra we talked before. For condition part, you can have many combinations of them. Yeah. Okay, so this is for the update. And then the next page, you can see the query part of the updates, right? So this is the one we utilize a query. So again, I'm going to skip for right now. So now we know the basically statement to do insert, delete, update. We also know how to create a schema. So now if you have a database design, say for example, a relational model with those tables, primary key, foreign keys, you should be able to create your database, right, with those tables, also insert records and modify your records. So database is there. So the next thing we need to do is to see how can we produce the queries. Okay. Okay, so we finish this. We are going to move on to the query part. Right? So once we produce a database with tuples, and the most important thing is how to run queries. Where is my starting point? Okay, so for query, compared to insert, delete, update, even compared to create table, drop table, alter table, the query part need more human intelligence to answer. So create tables, insert, delete, update, that mainly syntax oriented, right? So once you know one example, you should follow that and relatively easily to create another table. Okay, but for query, we have a lot of like different kind of variations, and you sometimes need to think, what is the best way to answer and how can I answer this correctly? Okay, so SQL query is so SQL itself is a declarative language. So mainly you tell the query processor what I want to get, right? And then they will do it for you. But in order to do that, you need to give necessary information. For queries, there are totally 6 clauses. So this is select from where, and I'm going to talk about others. I'm adding others. This is more like a basic ones. So, so let's see what kind of thing we need to tell the query processor. So we need to tell the query processor the front part, which table you should use, the query processor should use, right? So tell them which table. And this is the one can be many tables. Say, in order to do this query, you need to use employee table, you need to use department table, and we can separate table by comma. So we just use comma to separate, say we have, for example, employee table, and we have department table, things like that. So we use comma to separate them. So that's the first thing you tell the query processor, what tables. Okay, so this is not like exact like declarative, like we think like for, you ask somebody, I need this one, they will give everything to you, but for query processor, you need to give them a little bit more detail tables, right? And then you tell them exactly what the attributes you need. For example, I need a first name, and I also need last name. So also comma separate what kind of attribute you need to see in your final output. I need 2 columns, and that's the 2 columns here. Okay, and the where part specify the conditions. So when they give you a huge amount of possible result, you want to use this as a filter and specify what kind of condition you want to filter them, right? So you may say first name, maybe you say you want to say department name equal to CSC, things like that. So that's basically a filter. We are going to talk about the detail of them one by one, but that's the basic structure here. So one interesting thing is, I know we just finished the relation algebra, and for the select, please don't be confused on this. The select here is not equal to the select operation in relation algebra. They are different. Actually, the select operation appear in where. Okay, so where can have many conditions. Some of them actually contain the select operations filter. So this select in SQL, this is similar to the projection, the project operation in relation algebra. Okay. So that's something you don't want to get confused to think the select is that select. They are not. So this is a schema we're going to use to run SQL query to give examples in this PowerPoint slides. Okay, and let's see one simple query. So what I would do is I give you simple ones and I'll add more things and more things, more clauses. So this way you can do more complicated at the end. And most people feel it's easier when you move on to SQL compared to relational algebra. Hopefully that's the case here. So let's see, we want to get the birthday and the address of employee with this name. This will be kind of question you will get in your final exam. So I'm going to give you a query something like this, not exactly this one, okay? And something similar, I give you a description and you're going to answer the query using SQL like this. So we say select from where. You can start with anything, but my suggestion is it is always easy to start from the from clause. You first want to identify which table or tables do I need in order to answer the query. So in this case, I have everything coming from employee table, right? So that's why I only have one table and you can put a table here. So identify the table first. Then the next thing I want to do is I want to see what kind of filter I need to do. And this one tell me I need an employee whose name is this. So if we go back to the schema, we can see first, middle, and last. So that's why we have first name here, and you see and here. So this one you need to know how different conditions they are related. This is and, or this is or. In this case, that's as and, right? So you just put and here, and then you put and here. So everything I type here is uppercase, but whether you do uppercase or lowercase on those, right? So you have to see how you define when you create your table. What kind of thing you define, you need to follow the create table statement to see exactly the same wording there in the attribute name and to put down here in the table name here. Okay, so so we get this done. So we filter the employee already. Not every employee, only when we have this conditions true. Then let's see final output. They want birthday and address. So that's why I found the B date and address, 2 columns here. Okay, so if we quickly go back to relational algebra, you will see we using set operation, right? So basically, everything the set means we do not have any duplicates, right? So if you say I have tuple A and another tuple A, that's is wrong. And because I cannot allow two tuple to be exactly the same. So that's for relational algebra. And for SQL, it is actually based on a bag operation. So that's mean by default, right? So this particular query produce a table output. And this table is a bag. So by default, I can have A, no problem. And also no automatically duplicate elimination. By default, it contains duplicated tuples. Okay, so in this case, okay, so let's see what is the table looks like. Let me get rid of this. Okay, so say my table. Okay, so my table here has B date as the column, first column, and the second column is address. Actually, you know, I'm supposed to do uppercase, right? So okay, so that's the 2 columns I have. And say I only have one John B. Smith. So birthday is whatever value and address is whatever value. You just only have one record. However, it is possible I have 2 employee all called John Smith, and then I have a second record of birthday and address. And maybe I have 3 persons called John Smith, and one of them actually is identical to the other one. Right? Most likely you don't have this case, but say you do have 2 John B. Smith with same birthday and same address. It can happen, right? Although kind of like not that highly possible, but still possible, right? So say this one and this one, they have exactly the same birthday and address. You do see this one show twice. So that's what I mean is a bag. We don't have duplicate elimination automatically in SQL. We be able to convert a bag into a set. So this is a bag. So we can convert a bag into a set. So this one can be done. Okay, and we have one slide showing this, and this is basically using this tick. So I give you a question mark here, and so then later we'll see how to do this. Definitely we can convert it back into a set if you don't want to see duplicates. Okay? Some of you curious, right? So if you remember, I said relational algebra is a low-level algebra presentation of high-level declarative language SQL. But one is bag, one is set. How can this work together, right? So the reason is when we actually, the graduate course I'm teaching, talk about, the query processing, the details. When we talk about the actual relational algebra present SQL, we have extended relational algebra to extended relational algebra into a bag, and also with additional algebra operations to handle it. So that's why how things work, right? So in case you're curious, but for 134 class, you don't need to know that many. You just need to know SQL is bag-based by default. We don't limit it duplicate. We can have duplicate. And the relational algebra is based on the relational model foundation, the theory of relational model. It is set-based. So automatically duplicate get eliminated in the relational algebra. You learn in this 134. Okay, so this is the very basic SQL query. And let's see another simple query. Okay, this one asks the name and the address of employee who work for the research department. And so compare to the previous query, you can see it seems that we do need a little bit more than just the employee table to get things done, right? And some of you probably recognize that we had this query somewhere before in relational algebra, right? Yes, we did, right? So if you still remember, what we had is we produce a select operation. And actually, I'm not be able to do this without the pen. So we have a select operation, and using the select operation, we be able to get a research department only, right? Remember, we filter out. And then in order to say department employee, the employee work for department, and that is using employee and department, right? So how can we say employee work for the department? We join this table with this table, right? No, all right, so sounds familiar. And we actually can do same thing here. Actually, the job is easier here. Let me just put a select from and where here. Okay, so from part, I want to say which is the table, right? I need to tell the query processor what are the table I'm going to use. And since we already identified, we need the employee table, right? Because this one actually the name, right? For employee, definitely we need the employee table. And then we use a comma to separate that. And the next one we need is the department table. So we need a department table. So using comma to separate them, and always at the end, SQL statement, actually I can put down here, we use semicolon, insert, delete, update, also create table, any of them, you use a semicolon to tell the query processor, I'm done with this statement. Okay, because you can, like this case, you have 3 lines, right? This is one show, it's done. And this is comma to separate different table. Don't mix up the 2 things, okay? All right, so put this at the end. So I have the table. So once I put it in a table, they are automatically considered as Cartesian product. Right, so this one, be careful when you put more than one table. The underneath operation is a Cartesian product of 2 tables. And we already know, since we had this in relational algebra question, we don't want to do Cartesian product. We want to do a join operation. In other words, after we do Cartesian product, we need to do a selection, and the 2 operation combines actually is a join operation. So what matter is, what is the condition to join them? And that's something we should put in the where clause. So where clause, I'm going to put the condition, and that's the D number equal to DNO. So that's this one. So DNO equal to D number here. So which one you put first? Can we do DNO equal to D number? The answer is yes. Remember, this whole thing where give you a true or false answer. So DNO equal to D number or D number equal to DNO give you the same true or false answer. So that's why you can, using any order, and similar, you can do AND, right? So if we have something and something, whether this one first, the statement first, or those things after that first, doesn't matter, because the whole thing, remember, as long as give you the same where clause true or false answer, then you can do any order on that. So the AND statement here, because we have to have another, we need to have another filter, right? Another condition in the where, that is, we need to restrict them to be research department. Okay, so remember we had to select the symbol there, and to say research department, so D name equal to research, and this is the single code. Okay, and now I ready to put the single column here. All right, so I have the filter. Now I need to tell the query processor the last thing is exactly which attributes you need, and they need a name. So we can put like a can put first name and maybe middle initial if you want, and last name, right? And then address. And so usually, the order of this is same as the order they specify. So they say name first, you do name, and then address. Okay, so then you see this query is done. You can see the join condition actually appear here. Right? So remember the join in the relational algebra, that's actually appearing here. Also the select, right? There's a condition in select operation in relational algebra also appear here. This part, the where clause, actually taking all the filters, everything, like all the conditions can be in the where clause. And make sure you do the right and the or operation. And you can use, things like this, something, for example, A and A is a condition, B, or, C or D, something like that, right? So any condition you want to specify, always, even you have and or, it's better you just make sure you tell the query processor what's the right order to process it and to avoid unnecessary confusion when you expect a certain result. All right, that's it. That's all.